Okay, Assalamualaikum and welcome everyone to Faculty of Engineering Leader of Enterprise. So my name is Shabuddin Bin Mat from School of Mechanical and currently head of UTM Aeronautical Laboratories, or we call it Aerolab. Aerolab is one of the UTM Center of Excellence. Today we are today we are fortunate to have Mohamed Bachik from Sanmina System Sdn Bhd. Okay, so it's a world-leading technology in computer and telecommunication. Actually, Mohamed Bachik is currently a senior engineering manager for this company. I am proud to tell you that Mr. Mohamed Bachik is UTM aeronautical alumnus. He graduated bachelor degree in aeronautical engineering in 1997. So, I would like now to invite Professor Shuhami bin Mansur, Assistant Dean for Global Engagement, to welcome Mr. Mohamed Bachik to deliver the talk today. Yes, Professor Shuhami.
Assalamualaikum warahmatullahi wabarakatuh. Thank you, Engineer Dr. Shabuddin bin Mat. So today, actually, we are going to have another series, the series number 9, Leaders of Enterprise, brought to you by the Faculty of Engineering UTM. Today, we have a special guest. Actually, he is the classmate of Engineer Dr. Shabuddin in UTM. So we would like to say thank you so much, Encik Mohamed Bachik, because accepting our invitation, and it's our privilege to have you with us today. So please welcome Mr. Mohamed Bachik.
Hello. Assalamualaikum and good morning.
Hello Bachik, how are you?
Good. How are you?
It's been some time I haven't seen you. Yeah, long time ago, yeah?
yeah. Since 1997.
1987 or 97, right?
97.
Yeah. So welcome back to UTM in the virtual world.
Yeah, thank you. Thank you for having me.
Yeah. So yeah, we would like to say thank you so much for accepting our invitation to be one of our leaders of enterprise for today webinar. Yeah. So maybe Bachik, you would like to introduce yourself since you left UTM?
Oh.
So the viewer on maybe the other guys or the other what we call it, visual would like to know more about yourself actually. Yeah.
So I graduated from UTM in 1997. So I'm from Penang. So I applied a job in manufacturing. Got a job in Motorola manufacturing in Penang. So I'm in the organization that is the manufacturing for Motorola, and this organization has been sold to Sanmina in 2016. So basically, I still work with the same old guys and the same organization and the same building, but it's just a different company now, Sanmina. So in our slides today, we will share the journey of this organization and also the company Sanmina that we are representing.
Okay. Yeah. So since your graduations, you're just working with one company, yeah?
Yeah. It's one company.
Yep. So your position now is senior engineer at Sanmina CSI, right?
Yeah, senior engineering manager. Yeah.
Yeah.
So I'm actually focusing a lot on industrial engineering.
Engineering.
So part of our team is doing all layout, the capacity planning, the way or quotations for work required for new customers and stuff. And also one of my responsibility is also on automation, on simplification of work, mechanization. So it's all the work required to make our operations more cost effective, more efficient.
So your company dealing with more, I mean, electronic system or electric manufacturing
Yeah.
system.
So Sanmina focus a lot on electronics and electrical products.
Okay. Okay, I think the viewer would like to hear more about your title today. Is something, I think it's not something, it's very interesting because your title is demystifying about the Six Sigma. I heard about Six Sigma. Yeah, it's when I learned statistics, and you know that you deal with the Six Sigma, yeah, Sigma. So I think this is today very interesting because Mr. Bachik will share with us the misconception about this Six Sigma. So we would like to hear from his experience directly, yeah, applying the Six Sigma. So in terms of manufacturing, production, and actually how to deal with people as well, yeah, problem solving. So yeah, Mr. Bachik, so thank you so much. We would like to share with you and with the viewer all. And then please, I pass to you, over to you, Mr. Bachik, for your
Yeah.
presentation today. Yeah.
So I would like to share my screen because we
Yeah,
prepared
sure.
some slides.
You can share your screen first. Yeah.
So yeah, so thank you so much. We would like to share with you and with the viewer, and then I start to you over to you for your. So I would like to share my screen.
So can I start?
Yes, sure. Yeah, over to you,
Okay.
Mr. Bachik. Yeah.
So firstly, I'm very honored to be given this opportunity to share our experience in this forum. So I'm an alumni of this great university. I'm very grateful that the degree that this and the training that the UTM has provided has enabled me to come out and serve in our industrial nowadays. So a little bit on Sanmina, okay? So Sanmina is actually a global electronic manufacturing services. So Sanmina has 75 factories in the whole world, and we are present in 23 countries. So basically, EMS means we do not put our logo on the brand. The product that we build is contracted by our customers. So customers, big electronic customers, will have us to build their products, but the design, the software, it's all owned by our customers, right? So we are in the arm of providing services, building for them. Saying this, with you, if you could, because I don't want to mention the customers' names. So you
Yeah.
see the 75 manufacturing factories in the whole world. There are an array of big customers, small customers, new customers, seasoned customers that we provide products to.
Yep.
So the products that we supply to is focused more on electronics. So we are in the communication business. We are in the even the airlines. We provide systems for air transportation, for consumer banking, even for automotive. So we provide solutions to all of our customers that come to us for manufacturing of their products. Okay, some of our services that we supply enclosure, if there's any precision plastic molding, machinings that we can supply services to. Data storage, we build data storage for a lot of companies. Printed circuit board assembly, optical cables we supply, SSD, the DRAM storage systems we also supply, and so for backplanes we supply. These are some of the services that we could manufacture and supply and support our customer that support their own customers. So we will introduce. So I work in Sanmina Penang Plant 2. So if you drive from to Penang from the second bridge towards Penang, right? So the first exit that you take from the bridge, you'll see a building with this logo. So this is Sanmina Penang. So I work in this building.
So you're inside the building then.
Yeah, inside. It's a small inside. So basically, historically, this building was manufacturing site for Motorola for many years. Then Sanmina, as a global manufacturing, interested in this manufacturing arm and bought over this building and the equipment and the management in 2016. So you see, if you are a product company, you will always focus on a cost problem of your customer, right? So if you are a product company, let's say you are in transportation business, your strategy will be, how can I produce low cost transportation to the masses, right? Or if you are in the healthcare business, you will always have a strategy that how can I provide healthcare for people with heart bypass or something. So you will always have a strategy or objective on the customers, right? But if you are a EMS, that means you are providing manufacturing of goods, and your customer is another customer, right? It's not the end customer. And in this business, there are also many other competitors. So you need to have a strategy to make sure Sanmina Penang Plant 2 is different from other companies, right? It's a niche, right? So what Sanmina Plant 2 believes in, or our strategy is, to produce good quality products at cost. So the word at cost means the cost has to be continuously reviewed. Meaning if we can improve our process, if we can do things better last month versus this month, last year versus this year, the cost will be better, right? So this way
Yep.
we can be in the game for a very long time. So I would like to share with you the strategy that we have in order to make our cost competitive. So we adopt a strategy called the Six Sigma. So we are using Six Sigma as a strategy to make sure we can continuously improve the processes, the material, the quality that we have, so that it will fulfill our customer requirement, right? So this slide is showing the history of Six Sigma in Plant 2, our plant. So our plant started operations in 1974. So we under Motorola over the years. Motorola developed the Six Sigma methodology. In 2009, Motorola tried to integrate the Six Sigma with the Japanese lean manufacturing. So at 2016, Plant 2 joins the Sanmina family. So Sanmina actually adopted all the philosophies and the methodologies that we had in our factory, and they even exported some of our good practices to other of the 75 sites in Sanmina, right? So we still continue whatever that we are doing since 1974, and today we'd like to share with you the things that we do, right? So if you go into the internet, right, and search for Six Sigma or Google, right, you could see there are many definitions of Six Sigma. So it's like the seven blind men trying to identify the elephant, right?
Yeah,
So,
I understand that.
so different people, if you search Six Sigma, they will say it's 3.4 ppm. Some will say it's a DMIC methodology. Some talk about belt systems and stuff like that, right? So we would like to share with you our version of Six Sigma and how to use Six Sigma to get results in manufacturing. Because if you have all the methodology, if there's no implementation, there's no carrot, you might not get results, right? So this is the sharing on the whole methodology that we are using to drive our existence in EMS game, right? This EMS is a business, is a very fierce competition business, right? So
Okay.
if we talk about Six Sigma, three things that come into mind is the management system, and it's the problem-solving methodology, and also it's a quality index. So we'll go through management system, right? Okay. So one philosophy that Penang Plant 2 holds is whatever we do can be better. This year should be better than last year. This month should be better than last month, right? So this is the philosophy that everyone who works in Sanmina has to look into their area and to see if things can be done in a better way. And if he has done it for the last month, he has to look at it this month again. So it's the never-ending pursuit of perfection, right? So this is the methodology that we use to make sure we have thousands of people working in Plant 2. So this methodology cannot happen for 200 people only. This methodology and this belief must be for all of the employees, right? And continuous improvement cannot happen only in operations. Continuous improvement has to happen in HR. It has to happen in the security department. It has to happen in the janitorial services. Even planting the gardens, right? It has to happen. I know we talked about a project the other day on how to install hydroponic vegetables, right? So that our employees, when the tomato gets ripe or when they can take home, right? So the key point is it should not happen in operations only. So for our whole organization, we think of a way. The first thing that we need to do is we need to make sure that people are not easy with the current status quo. We want to make sure that people are always looking for ways to improve, right? So that's the first philosophy. If people want to improve, the next step is how to. So that is where Six Sigma comes in. So Six Sigma is going to talk about how to, right? So do you want me? I think I just go through my whole presentation, then we can stop for Q&A. Is it okay? Then
Yeah, that's fine. Yeah, okay. Yeah, over to you. Yeah, you can. Yeah.
So if we talk about Six Sigma as a management system, right? So you can see in an organization, we have a little people in management, then we have more people in engineering or the technical ladder or the middle management, and then we have the masters in the operations, right? So what we do is we have different programs for different layers. So this is an inclusive program that everybody needs to contribute for improvement in our factory, right? So for management and engineering, we have a system called the belt system. And for the operations, we have a teaming for excellence, right? We'll go through just a rough idea on how this is done. So for training and belt system, basically, we have recognitions in terms of green belts and black belts for our management or engineering or middle management staff, right? So anyone from engineering are encouraged to enroll themselves as a potential green belt candidate. And we are a potential green belt candidate, you will receive training. When you register yourself, you'll get practical, some online training, some instructor-led training. But those are training, beautiful PowerPoints only. You need to convert the training into actual savings for the company. So I put XXX, it's a bit proprietary to tell how Sanmina will recognize someone as a green belt. So you need to do projects worth some amount and certified by the Sanmina Finance, then you can get the green belt. So for a green belt candidate to be a green belter, he has to go through Six Sigma training and also some criteria to complete projects, real projects that benefit Sanmina. And the expectation is after he's been certified as green belt, he has to lead more projects, right? And similar for a green belt, they can always do a black belt. So black belt is more targeted to high value complex projects. And then more training is done on these black belt candidates. And of course, the criteria of getting a black belt in the actual certification is more value, the more savings than the green belt, right? Okay, the expectation for a black belt is to mentor green belts. So now we have black belts that can mentor green belts. So if you go through a classroom training and then you do a project, sometimes the tools that is taught does not address the projects, right? So we always have mentoring, right? And then we have the master black belt. So I was awarded the master black belt in 2013 because I was mentoring a lot of people in the green belt and the black belt. So normally my mentoring is after 5. So people with projects, they will come and see if they have issues, trying to solve or trying to determine root causes or doing some confirmation, right? And the expectation of black belts and master black belt is to conduct training. So that conduct training is going to benefit the people who are in green belt or black belt that requires training, right? So it's a vice versa thing that the knowledge and the know-how and the expertise will grow, right? So we have a community of Six Sigma in the whole factory that goes through all these systems here. So if you understand the black belt system, that you are trained and then you need to have projects and you'll be certified. Okay, and the expectation is after you have certified, you have to do more projects, and also you have to mentor people and you have to conduct training. So you can be an ecosystem that this know-how of Six Sigma complex statistical tool is done over and over again, and over time these people become experts, right? It's not a one-time deal, right? And on the operation side, we have also training and also teaming for excellence. This teaming of excellence is basically something similar to QCC circles. So what we do is we encourage all our operators to form teams, right? So maximum team is 8 person, and then they will solve factory issues related into their area. So if we are in the front end operations, normally they will create teams in the front end to solve the front end issues, right? Using DMIC. And normally in the teams, they will have 1 or 2 green belts or black belt that will mentor them on problem solving methodology or data collection or using the right tools to answer the right questions. So those are infrastructure of encouraging people to have training and encouraging people to do projects. So as a carrot, every year without fail, our organization will host this TFV competition where teams will join, the operator teams will join this competition. You can see the picture on the top left is actually a poster display. So every year, this is I think 2019. So this on 2019, I think we have 30 teams. They will have posters to share what is the project done with a group of judges. And then the picture on the right, out of these 30 teams, 12 teams will be selected to do a presentation competition again. And actually some of the judges are coming from UNIMAP, USM. So we try to make judges who are also independent of our factory, because the factory judges have favorite teams, right? Especially the front-end manager will favor front-end teams, right? And then these top 3 of our teams, normally we send for the Northern Region MPC competition. That's where we join. So it becomes as a reward. And then if they are chosen by the front end, by the MPC, they will share in the national MPC competition, right? So last year we got Anugerah 4.0, 2 Anugerah 4.0 for 2 of our teams in, I think this in Genting Highlands, I think. And then the picture on the bottom right is actually, even in Sanmina Corporation, they will have competition among Sanmina factories. This is in Bangkok, Thailand, right? So I think our team was the champion in 2019 cross-regional. This is competition between the South Asia and also China division. So basically, this is a carrot. So sometimes the operators get to travel if their project chosen. This is the carrot that the operators are keen to join teams to make improvement in their area, and all of these improvements are financially validated. So it has meaning. Okay. So this is the summary of how Six Sigma is used in terms of management system. So on the other hand also, sometimes Six Sigma is defined as this DMAIC or this Kaizen. It's a tool now. So we are talking about Six Sigma as a problem-solving methodology. So different problem has different complexity. We are not saying all problems must follow DMAIC. If we have a simple problem, clear root cause, immediate implementation, we have a system called Kaizen that you do the immediate implementation and you document your before and after the improvements, and then you submit for finance validation, and then you get some points. This is to encourage that not all problems should be done in an elaborate way. Simple problems can be implemented and you're going to get reward. This way you can guarantee that the masses of operators in the whole line, right, can make improvements, right? And then that's on the left. And then that's on the right-hand side. If you have a complex process and it's multiple causes and it takes 4 to 6 months, Six Sigma have a methodology called DMAIC. So the potential green belts and black belts are trained in this DMAIC methodology, right? Because rather than a problem being solved in so many different ways, Six Sigma is saying problems should be solved in a methodological way. So that in each phases has each tool so that people do not miss out. So it is a standardized way of looking at the problem in a statistical way, right? So the first D is to define what is important. So you have so many problems in the whole organization. A D for a security manager might be different than a define for an operations manager, and might be different for a define in the test engineering, right? So key point is you have to define the problem and how big is the problem, meaning how much Sanmina is losing a year if we don't do this problem, right? And then what is the scope of this problem? Is it potential that this solution is only for Penang, or can it be cloned into Bangkok, or can it be cloned to China? So this is the area that we define projects, okay? After that, we have defined what projects is important. We need to define the metrics that is going to represent the success of this project, right? Then we need to baseline the performance, and then we'll put a goal setting, what we expect, what the customer expects us to do. So that is in measure phase, right? So we will have a problem if what we are doing now versus what the customer wants us to do, if there's a gap, right? The bigger the gap is, the bigger the problem is. So actually in A phase is to brainstorm on why we are having this gap, right? List all the potential root causes, and then doing some experiments to confirm if we can rule out some root causes, or if there's a dominant root cause towards having a gap in the M phase, right? So once we know what are the root cause or root causes, or what are the points that if we change it will affect the whole project, I is all about creativity work, innovation work, right? It is about benchmarking if other industries, in the other industries is having that problem, or see if any solutions that's already available, or generate pure innovative our own solutions, right? So in I phase is a lot of creative work. However, all creative work must be ruled out or must be reduced into effective plans. And plans and pilots are implemented in I phase to make sure that whatever that we have brainstormed as a solution can address the problem in D, right? C is, after that we have confirmed, is how to implement. We need to guarantee performance. Maybe we need to change the control limits in the control charts. Maybe we need to change some SOP or change some, do some more training, emphasize on some automation. So that is on C, right? So I just now was a portion that Six Sigma is also a methodology, right? In terms how to approach the problem. Okay, so Six Sigma is also an index. Okay, so later at the summary of this whole presentation, we will show you how this 1, 2, 3 are all linked together. Okay, so Six Sigma is also an index, which is a ratio of what the customer wants divided by what can we do. So some people call it VOC, voice of customer, and voice of process. So example, our customer is ordering for us tubes, like steel tubes with the diameter of 50 cm plus minus 0.5 cm, right? So if we have A, B, C factories or processes producing this aluminum steel tubes, okay, so the first thing we want to do is to measure the diameter, and assuming this is the measurement of all this diameter, the raw data that is coming in, the first work is to plot this raw data, right? You can see process A has this 30 tubes coming in these dimensions, process B has this, and process C has that, right? Then we plot in what the customer wants. Okay, so as you can see, so the index is called CP, which is a capability index. We call it in Six Sigma, capability index. So capability index is the width of process A, which is the blue dots, right? So you can see this has a lot of variation, right? So what the customer wants is the line between the red line divided by what we can do, which is this width, right? So the CP is relatively low. But the ratio of process B, which is the length of between these blue red lines, divide by this variation here. So big number divided by small number, of course the CP is higher, right? And we can have CP in between, right? Okay, so we take whatever data into a histogram, right? So this Six Sigma is coming from this Gaussian distribution. So similar thing, we put what the customer wants, okay? And then the red one is actually the process B, that a lot of these tubes are coming in a diameter between 49.53 and 50, right? And some for process C is coming at this distribution, and process A is coming with this distribution. So the ratio of this divided by this is the CP, right? Which is called the capability index. So CP is called capability index, equals to what the customer wants, upper spec limit divide minus lower spec limit, divide by what is the variation that is coming from the process, right? So in Six Sigma, the ground rule is CP must be more than 2, then you are deemed as a Six Sigma process. So more than 2, because this is 6, so 6 times 2 is 12, right? So it's 12 deviation here. So this distribution has a Six Sigma characteristic. That means this process is deemed Six Sigma, and we always want to make sure our processes are Six Sigma. Okay, so if we take the raw data and put it in the calculation, we can see for process A, this is 0. I cannot see 0.852 maybe. So this is important, 0.82 I think, and this is also important. This is prediction of number of rods, steel rods that will be out of the lower spec limit and the upper spec limit. So this is the prediction. So we can say this is in parts per million. So you will have 100. No, it's 14,000 steel rods in 1 million will be out of what the customer wants if we choose this process. So this is B. BCP is 3.85, which is more than 2, which is Six Sigma capability. And then the prediction in 1 million, there will be no fallout. Process C is 1.47. The prediction will be, because this is not going to touch this line here forever, right? So it's going to go, but still, there's some fallout here. So the prediction is 10.23, meaning in 1 million steel rods, 10 will have out of this spec limit. So sometimes they say Six Sigma is 3.4 ppm. It's actually coming from here. So if you get a CP of 2, then you can see 3.4 will be here. So it's just to predict that how many percentage in 1 million will be out of spec. Okay. So that is the meaning of Six Sigma in terms of an index, right? What the customer wants divided by what you can do. Okay. So normally in Six Sigma index, it is used to measure in the measure phase and the control phase. So after we define what is important and what is in the measure phase is what the customer wants or what the boss set as a goal divided by what we can do. And that gap is actually addressed in the analyze. And once you get the root cause, improve is to brainstorm and be creative, but you need to confirm the true action plan. The thing that if we improve, it will improve the whatever metrics that we define here. And C is actually to confirm that, yes, we have achieved Six Sigma performance on our process, right? Okay, so we shared with you that for management, we have a methodology that they can do Kaizen or DMAIC. Engineering is the same. Operations is also the same. And by doing so, if anyone could be certified a green belt or the black belt, if they take the course, they prove that they can make the projects with the required savings, and then they continuously make improvements. These are some recognitions that our organization provide. Okay, so in the next show, I don't know, in 38 minutes, right? That is the summary that we have in terms of demystifying the Six Sigma. So is there any question?
Thank you so much, Bachik, for your interesting presentations. So we will wait for a question from our audience, Bachik. In the meanwhile, maybe I would like to know a little bit about your Six Sigma. So the thing is now Six Sigma is used as a quality index, in your contact, right? It's a quality index.
So the consultant always say it depends.
It depends. Okay. Mm-hmm.
So I mean, if it's required as a Six Sigma, it's an index. Is how good is it? Will be based on what the customer wants. Yeah.
Then
solve it, you can use DMAIC.
Yeah. Looking at the statistics point of view, sigma is basically the standard deviation, right? Correct me if I'm wrong. Yeah, it's standard deviation. Correct. Yeah. So now the point is how you define the index, which is the standard deviation, according to the performance or the target that you want for your anything that you want to do for the products. Yeah. How do you define that? You compare with others, or you set the point, set the numbers, values?
Okay, actually, if you look at this example, what the customer wants is only this, right?
Mm-hmm.
That's what he wants. Okay.
Yeah.
So we take the sample, and then we could see that process. Okay, if a 30 sample already have this type of distribution, right? We can predict for process A, if you don't do anything, some will come even further because this is only 30 samples. Imagine running 1 million.
Yeah. Okay.
So this is the work of this one, prediction of that 1 million. This is not the calculation of sample. This is the prediction of population. So
Yeah.
the
Okay.
sigma is actually the capability of the process versus what the customer wants. If the customer wants a spec here to here, maybe this process is okay.
Okay.
So we don't have to beat the hell of the until we can get a very tight spec if it's not required, because if you have
I
tight spec,
see.
the cost of the manufacturing will go up.
Sure. Okay. Understood. Yep. Thank you. Yeah, Mr. Bachik. So maybe
Yes,
we
sir.
have we have
We have
question
a
from
question
audience. Yeah. Yeah.
from Professor Nordin just now. We have a question. Yes, Professor Nordin. Can you answer that, Mohamed Bachik?
Yeah.
Can you read
Okay.
the
Can
question?
you read the question, Bachik? Yeah.
Yeah, question for Mr.
Yeah,
Mohamed Bachik. Oh, that's me, right?
universities can provide knowledge, information of Lean Six Sigma technique and tools. Yeah, only limited opportunities and are available at university to provide actual hands-on experience. So, in your opinion, how can companies assist universities to enrich the training of our undergraduates, meaning future engineers, in this respect?
Yes.
I actually, even in universities, right?
Yeah.
I don't know if all the processes in universities are they Six Sigma.
No, I think the question is what kind of training to this, to
Yeah.
enrich the
So
student.
I'm saying,
Yeah.
yeah, I think maybe it's the define that we need to do, right? It
Okay.
can be even in a factory. It's a actually I want to say it can be applied anywhere,
Yeah.
something like that, because not all processes are perfect, right? If
Yes.
we have a
Okay.
methodology that can be improved, I don't know, maybe a small shop, right, that is selling, maybe the cafeteria, right? If that's what is the queuing time for cafeteria, right?
Yes.
But if that's why the define is important, we cannot solve a $1 problem with a $10 solution, right? If
Okay.
it is a big problem, then we can resolve it. If it's a small problem, so actually Six Sigma can be applied in manufacturing, in anywhere that we have a gap into expectation and what the customer wants. Example, right? If the class between the interval between class is 10 minutes, right? But the lines to take the food is more than 10 minutes or what. So those are opportunities that we can identify,
Okay.
right?
Yeah.
On
Maybe
industrial, I don't know. Maybe the question is on industrial.
The thing is something like this. So okay, maybe Bachi already been experienced as a student, in UTM. So how we can expose, the student with current limited environment where we can get more practical appreciation about this Six Sigma to the students. So do you have any what kind of training to the student or any additional to the whatever enhance to the program for
Yeah,
students?
actually, the training provided by UTM is very good. It's excellent.
Thank you.
Is
Thank you very much.
maybe the implementation, the hands-on requirement. Maybe that is the challenge, good.
Yes, that's right.
So
Yeah.
as much as we can do is only in our organization. Yeah, I
Yeah.
think we have internships and stuff, but UTM have never. No, I've never experienced good UTM, right? So maybe it's a bit too far. Eh?
Yeah.
So internships that we can do, but the point is, I don't know. Maybe it's because it's the practical implementation. You need the whole factory to do it, or
Yeah.
the whole. Yeah.
Yeah, something that whole in the experiments or yeah, the syllabus,
A question
yeah,
there.
second,
Hello,
there's
Mohamed
a
Bachik.
second question, from Lee Yi Fong, Bachik,
Oh yes.
The question is, if a company already have ISO, where it focus on improvement too, does it necessary for that company to apply this Six Sigma? And what is the difference between ISO and Six Sigma?
So I assume this is ISO 9001, right? So
Yeah,
ISO
probably,
9000,
yeah.
9001 is to document your process, make sure everything is documented, and there are many tools, many methodologies to do improvement, right? So what we are sharing is what Sanmina Penang is using as a improvement methodology. So the Japanese have the PDCA. I think automotive will have the FMEA and all the. So it is no harm. It's just that we are sharing how this methodology is applied in Sanmina.
Yeah, we have one more question.
Question.
Yeah,
So in
Rizwan R.
Sanmina, you get paid, right? So I mean, in Sanmina, if you are an employee, you have to participate in this continuous improvement. You have to go to courses. You have to prove that you have that much savings, and the saving goes to the company. So and then you get your salary, right? So I think that's how we do it in Sanmina.
Yeah.
Maybe you're thinking as a outside cost, but I don't know what is the cost for the outside.
Yeah, we have one more
Mohamed Bachik.
question from Prof. Shari. Yes, Prof.
Professor
Shari.
Sari.
How much of design of experiments used in Six Sigma projects? Bachik.
So the consultant answer is it depends. Because we believe the right tool for the right questions. If a tool, if a question we need to answer by doing DOE, we will do a DOE, right? So it just depends on the right tool. Because in Six Sigma, we emphasize that if you have a plumber bringing one tool to your house, if you have a leak problem, right? He brings a hammer, right? So you're worried, right? Because he is only using one tool. But if you have a plumber carrying 20 tools and use all the 20 tools, you're also worried, right? So it's just the right tool for the right problem, right?
Yeah.
Okay. So another question there. Six Sigma purpose is to solve business problem nowadays, but how it works, and can give one example which industry use Six Sigma technology.
Yeah. So actually, that's why we presented the Six Sigma. That Six Sigma is a management system. It is a methodology, and it's the index. Okay. So if you want to use, if you have a company that's running manufacturing and you want to make sure everybody is running continuous improvement all the time, maybe you can implement the management system only. But it'll be a big disadvantage, because you need to also, since you say, hey, improvement is very important, then your operators are all charged up to do improvement, but you don't provide them the methodology, then you have to teach the tools. So that is why we present it in such a way that it's all interlinked. We cannot look at it as an index only. Maybe the benefit is that much. If you look at DMS IC only, then you teach your operations to do DMIC. but there is no management system to encourage people to do DMAC over DMAC again over DMAC, right? So that is what I think.
Yep. Thank you. Yeah. Yeah, Sabudin, we have more question. Yeah.
So Six Sigma is
Which is-
about
Yeah,
DMAIC methodology. So Lean Six Sigma is actually putting more tools into DMAIC. Like in value stream map is in M. So in the traditional DMAIC, the Motorola version, it didn't have a value stream. And then, so we are talking about the right tools to solve the right problem, right? So value stream map is good indicator, is a good tool to measure how batch and queue is the layout, right? So in the old DMIC, it doesn't have this tool. So, so the word Lean Six Sigma is putting lean tools into the Six Sigma framework to address maybe lead time, to the operator efficiency.
I see.
So it's just a name that
But the whole concept is Six Sigma. Yeah, the whole concept is Six
is
Sigma.
reduction of variation. Yeah. Even in lean, it tells you an operation should get 50 in an hour with 10 operators. And sometimes there's variation. You don't get 50, you get 48. Sometimes you get 52. So for me, 48, 52, it's okay, right? But you are getting 30 versus 50. So that is a variation, right?
Yes. Yeah.
Yes. So we need to use the right tool. So I know in 45 minutes we cannot talk about all the tools in Six Sigma, right? But assure you, there are a lot of tools, but the key point is use the right tool to ask the right questions and answer the right questions.
Yeah.
So a question there from
Nur
student.
Fazana. From Nur Fazana Amira.
Okay.
Yeah.
How
So
your
How your
company
company survived during the pandemic 19? Yeah, COVID-19. Yes.
one of our customers here is in a business which is a mission critical business that supplies a lot of things for emergency use. So actually, since the MCO1, we've been working actually. We get some approval from MITI and we've been working until now because we are providing those important equipments for one of our customers. So business is and because of the MCO1 and 2, only limited production that has the mission critical stuff. The rest of non-critical is not on. So it's a bit down for the MCO1, 2, and 3, but now it's picking up.
Good.
Yeah.
From Nazrin. Okay.
Yeah, Nur Azrin Muhammad. How are you, Nur Azrin? Assalamualaikum. I have question to our panel, Mr. Bachik. Since Six Sigma is about data collections, means that we need to have enough sample. Is this method applicable for non-mass production? How we can apply Six Sigma to non-mass production product? Yep.
So that's the whole thing. The thing we talk about Six Sigma is not about data collection only.
Yes.
I don't know. Maybe if I were to interpret this question, is this method applicable non-mass production? Okay.
Not Azrin is also alumni.
Yeah, but Six Sigma is a tool, right?
Yes, it's a
So
tool.
it has many tools, right?
Agreed.
So
Yep.
you use the right tool for your non-mass production. Actually, it depends on what is the question that we want to answer. What is the burning platform for this non-production?
Yeah. Accuracy.
Yeah,
Maybe precision. I don't know. Yeah, could be.
Yeah. So we just need to use the right tool for the right question.
Do you have any example kind of tool that to be used for non-mass production?
What's the meaning of non-mass production?
Meaning to say that the product is on demand. I mean, it's not for example, like building an aircraft. Yeah, you build by order. Yeah, not mass production.
Okay. But you build many aircraft, right?
Yeah, but based on order. Yeah.
Okay. Build to order, eh?
Yeah, build to order. Yeah.
Okay. So what is the okay? I don't know. So in our manufacturing, we have lines that is running non-stop.
All non-stop. Yeah, all the time. Yeah.
It's called popcorn. Okay. So we also have lines that is building stations, right? So those are slow moving, right? So for material delivery, for the popcorn lines, so it's just
Popcorn, you
continuous
call it.
flow.
Yeah.
Continuous flow of material with the reorder point to Kanban system. Okay, but for the slow mass production, right? Normally we keep the material to the station. So if this station has 5 screws, right? Only the 5 screws will be there, so that when they finish the work, right? All the screws are there, lah.
Yeah. Okay.
The O-rings. So those are for the custom or what the craftsman work, right?
Craftsman. Yes. Yeah. That's the word. The craftsman. Yeah.
That's the
Craftsmanship. Yeah.
so for those type of products,
Yeah.
so you can see even material delivery is different. So it's the right solution for the right problem.
Again. Yes.
We didn't say material distribution should be water spider for all.
Yeah. Okay. Yeah. Thank you, Bachik. So one more question from Faizul lah. How about the cost? How about the cost measurement? To do some improvement, need to do cost evaluation. Is Six Sigma covered this matter?
Cost of implement. So in define, normally there's a question, right? If we don't do this project, how will it impact Sanmina, financial wise? There's a question there. So it's in the team charter on the right hand side. It's called opportunity statement. That means we need to say, this is the pain Sanmina is going to experience if we don't do this project. So we have to quantify the project in D. Meaning even before you start the project, you already quantify the pain. Okay?
Yeah.
So in your eye, in which you are trying to be creative, so we have a philosophy, you cannot solve a $1 problem with a $10 solution. Right? You cannot put super sensors, blah, 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 where you put a fan, the whole empty box will fall away. So, right? So you already define the impact in D. So you will be very careful if you are in I. And even in I, even if you get the alternate solution, right? You always have to weigh if it's easy to implement, is it costly? Because Sanmina is running a business, right? All the money that we ask, we have to justify the outcome, right? So it is something that in Six Sigma, the discipline will be done, everything in D at the first phase.
Yeah. Understand that. Yeah.
Muhammad Afifi. This is from
Prof.
Professor
Afifi.
Muhammad Afifi, our former dean.
Do you remember Bachik, Prof. Afifi?
I think he don't remember me. I remember him.
Yeah, Prof. Afifi has a question there. The success of Six Sigma also depends on how an organization value its manpower. You value your staff as asset, not simply kaki tangan. You provide training, etc. What says you, Encik Muhammad Bachik? I'm sure their welfare is looked into as well. The carrot one, I think.
Yeah, I mean, so there is a philosophy since I joined this organization. Everyone is not hands and legs, all right?
Yeah.
So if we train people on problem solving, even for operator, okay, if he can go out and ask, actually a lot of our people who goes out, they get to be supervisors and stuff like that. I know a lot of even our middle management, they goes out, right? Because of all the training we invested in them, even if they don't like our company, but the value is they have been trained, right? So the way of thinking, actually we are changing mindset only. The first mindset that we change in our for new people in organization is about continuous improvement, being not happy with whatever status quo.
Be not happy.
And
with
you
it.
can
That's good.
and you can use any tool you want as long as it is going to be better.
Yeah.
That's the whole, because sometimes for new people that's the challenge that we have, right? They think work is about doing this only, right? Doing what they're told only, right?
Yes. Yeah. Thank you, Bachik. So
We
can
have
we
a
take
last
one
question.
more last question? Yeah,
One
from
last question
Hamid.
here, yes.
Yeah, from Hamid. Could Six Sigma be contributed to addressing environmental and societal issues and challenges?
So it's I thought I read somewhere in the U.S. presidential election, one
Oh.
candidate is trying to introduce Six Sigma in his party manifesto or something. So actually, it's just a methodology how we
Yeah.
look at issue, right? So the first methodology as a management system maybe is applicable if we run a business, right? So for DMAIC is applicable if you can address these environmental or social issues, right? In a way, in a DMAIC, and you can use whatever tools that is available there to achieve what you define.
Yeah.
It's just a methodology only. It's like
Yes,
any
the
other
methodology.
methodology.
Yeah. Yes. Thank you, Bachik. Yeah. Yeah. So, how is it? Is
Oh,
it
a question. Last question. One last
last
question.
question? Okay. From
What?
Helmi Haddad. Yeah. What are the flaws, critics, disadvantages of Six Sigma? So our last question, right? We are
Okay.
running out of time. Yeah.
So I don't know, because what we are sharing is what we are practicing over the years, and
Yeah.
and over the years, year after year, we get participation of all of our operators, and when they present the work that they do into their area, those are improvements that are verified by finance. Okay, and then it is a culture that everyone wants to contribute something. And if you do not know, there are mentors all over the place that could help you. You can ask any DOE or comparative method to. Most of the people are trained, and the way they think is a bit different. Okay, so it's just a tool that we thought it help us. Okay, maybe we will change the tool later. We don't know, but through the years, through these many years, we have seen it, and we are holding out to it until as of now.
So far, it's worked well. It works well.
So far, it works well,
Yeah.
and the tool has to be continuously improved also.
Yep. Yeah. Right.
That is
Yeah.
why the
Yeah.
lean
I agree
came
with that.
inside the picture. That is why we are even putting Industrial 4.0 elements inside.
Yeah.
And then we also have people talking about in our management Six Sigma 4.0.
Yeah. Yes.
So because
Another,
things
yeah.
change, we talk about continuous improvement. The tool must also change, lah. So
Yeah.
whatever is it, it's just a philosophy. We try to make it work for us.
Yep. Thank you, Bachik. Maybe Syafudin, we already toward the end, already ended the end the session. Maybe Dr. Syafudin would like to say something or closing the webinar.
Okay. Thank you very much, Mr. Mohamed Bachik, for very knowledgeable.
Syafudin, I
share.
think we have our dean here. Yeah, I would like
Okay,
to say maybe
okay,
we like to
but
say
we would
something
like to invite
to Bachik. Yeah.
Dean, Professor Rafiq. Professor Rafiq, you want to say something or you want to do closing first today?
Thank you, Shabudin, for introducing Mr. Bachik to me, and Prof. Shuhaimi as well, for arranging this UTM Engineering Leaders of Enterprise. So we have our leader here, Mr. Bachik Hussain. Thank you so very much for sharing your thoughts, sharing your passion on a very important topic of continuous improvement. in our personal quest to become better every day, offering quality products to our stakeholders, producing quality graduates. This topic is extremely important, and it is very, very entertaining to hear from you your thoughts
entertaining.
and your passion on this very important issue. So thank you so much for accepting our invitation to speak at UTM Engineering Leaders of Enterprise. And to all our viewers, thank you as well for watching. So I guess
you.
that's all from me.
Thank you, sir.
Thank you, Bachik.
Thank you, Bachik. Bye bye.
Okay, thank you. Bye-bye.
Bye bye. Assalamualaikum.
Thank you.
Yeah.